Hello and welcome to the Advanced Software Architecture course. My name is Imed Hammouda. This is a lecture on architectural tactics, part 1. In this lecture, we will introduce the concept of architectural tactic as a characterization of architectural decisions that are used to achieve a desired quality requirement. We will browse through an example catalog of popular tactics focusing on quality attributes such as availability, interoperability, modifiability, performance, and security. Generally speaking, a tactic is a conceptual action aiming at the achievement of a goal. For example, in the tactic board you see on the slide, a single move of a player from position X to position Y can be seen as a tactic to win the ball back of the opposing player. An architectural tactic is a means of satisfying a quality attribute response measure through architectural design decisions. For instance, we may want to consider an architectural solution to meet a performance requirement of average latency, or an availability requirement of mean time to failure. Architectural tactics are fundamental design decisions. They are the building blocks of architectural design best practices, expressed as architectural styles and patterns. In the example tactic board, a coordinated set of tactical moves can be considered as elements of a large game style. Note that individual architectural tactics do not consider possible trade-offs between different quality attributes. For example, an architectural tactic for security is not concerned as such with a possible degradation of system performance as a consequence of applying that tactic. A catalog of architectural tactics has been in use for several years in academia and industry, addressing different quality requirements. There are different tactics for each quality attribute. However, the same tactic could be relevant to many quality attributes. For example, restoring a system after recovery from an attack should be relevant for both security and availability. This lecture focuses on 5 quality attributes: availability, interoperability, modifiability, performance, and security. We will start with discussing architectural tactics for availability. Availability refers to a property of software that is there and ready to carry out its task when you need it to be. In fact, availability builds upon the concept of reliability by adding the notion of recovery. That is, when the system breaks, it repairs itself. More precisely, availability is the ability of a system to mask or repair faults such as the cumulative service outage period does not exceed a required value over a specified time interval. Availability tactics are designed to enable a system to endure system faults such that a service being delivered by the system remains compliant with its specification. When a fault occurs, availability tactics keep faults from becoming failures, or at least bound the effects of the fault and make repair possible. The figure on the slide shows a concrete availability scenario. The heartbeat monitor determines that the server is non-responsive during normal operations. The system informs the operator and continues to operate with no downtime. The categorization of availability tactics is depicted in the figure shown on the slide. As illustrated, availability tactics are categorized according to whether they detect faults, recover from faults, or prevent faults. Fault detection or anticipation is an important step before any system can take action regarding the fault. Once faults are detected, the system can recover from such faults through repair and reintroduction strategies. However, instead of detecting faults and then trying to recover from them, an architect could adopt other architectural tactics to prevent faults in the first place. please refer to the textbook if you want to learn more about the individual tactics. For instance, heartbeat is a fault detection mechanism that employs a periodic message exchange between a system monitor and a process being monitored. Note that it is often the case that these tactics will be provided to you by a software infrastructure, such as a middleware package. So your job as architect is often to choose and assess rather than to implement the right availability tactics or the right combination of tactics. Here is an example system showing two availability tactics in action: heartbeat and redundancy. A request is received from a user to access a service or a website. There are two load balancers used in the system, a primary one and a redundant secondary one. A heartbeat is configured to monitor the state of a primary load balancer. In the event that the heartbeat service detects that the primary server is unavailable, the system automatically directs traffic to the secondary server, which will act as the active server until the primary server becomes available again. Here is a question for reflection. Considering availability tactics, what are the performance implications of using these tactics? Think of heartbeat, for example. The time taken to detect a failed process relies on the frequency of heartbeat. Clearly, the higher the frequency, the faster failed nodes will be detected. However, a too high frequency requires too much overhead and may cause performance degradation. This is the end of the Architectural Tactics lecture, part 1. Thank you for watching.